Okay, this is a problem regarding which one is a molecular compound, and in other words, which one is the opposite of molecular compound. I would say is an ionic compound. So ionic compounds typically consisted of a compound that can be like to be develop the positive charges, which is what we call the metal, and then this counter ion that is negative charges. So the one atom that like to develop the positive charges, this is typically we call the metal, and the one here, this is an alkaline metal. They like to develop M plus. Example is lithium like to be lithium plus, sodium plus, potassium plus, rubidium plus, and cesium plus. They all always get rid of their extra 1 electrons on this first column. So that's why we call this alkaline metal. And the second one is always they prefer to remove 2 electrons, so alkaline earth metal. And the more common one is beryllium 2 plus, magnesium 2 plus, and calcium 2 plus, and so on. So this is always the metal. So and the one shown up in this yellow box, and this is what we call this the transition metal. And this transition metal has a multiple oxidation state, but still metal is a metal. So we look for the one that is a metal. This is a transition metal, copper. Sodium is a transition metal. Rubidium is there, and also Sr. This is another transition. This is actually alkaline earth metal. So we have here this one. Sodium is here, and the copper is number 29. So this is all in the metal except for this phosphorus oxide compound. So therefore, this is a non-ionic compound, which is a molecular compound. Okay, so this is a number 17, and this asking about which one do you expect to have a lowest melting point. So melting point is a measure of ionic interaction, ionic bonding in the compound. And the ionic bond model, this one is actually, there are two factors that affecting the ionic interactions in this ionic bond model. One is charges. And the number two is actually their distance. So ionic bonding is there are positive charges and there are negative charges, and this is bound together as a compound. And if, for example, if you have a 1 plus, 1 minus interaction versus 2 plus, 2 minus, which one will have a larger interaction? This one will have a larger, stronger interaction. That means melting points is higher. This is a higher melting point. Okay. In terms of distance, if you have, let's say, 1 plus, 1 minus in this small atom, atomic radius, versus 1 plus here, 1 minus here. So this is the shorter distance, and therefore they will have a stronger interaction. So that will also increase the Tm. So what we are looking for in terms of, let me choose a different color. So I want something that is lowest melting point. I guess a lowest melting point means smaller charge separation. Charges develop with the distance is larger. So let's look at that. And this is a calcium 2 plus develop, magnesium 2 plus, sodium plus rubidium. Where's the rubidium? Rubidium is here. That will be plus, and SR. That's SR is 2 plus. So as far as the interaction is concerned, this is 1 plus 1, and the fluorine, which is F minus, iodine minus. So this is a 1 and 1 separation. So in this case, C and D will be the case where you have a smallest charge separation. The now second category about the distance, which one is a bigger? Sodium versus rubidium, iodine versus fluorine. This is essentially this rubidium is, I can say the rubidium iodine is this big, whereas sodium and the fluorine is ion, plus and minus, and the plus and minus is this big. So therefore, this is a case smallest charge separation and the larger distance between them. So answer will be D. Okay, so this is another question about using the periodic table of elements. Now the question is about what is called the electronegativity, and in an order of increasing. So electronegativity develop in the atom because the proximity between the atom core, which is a nucleus, and the surrounding electrons. And the one element that has the largest electronegativity is a fluorine, and it's sort of the order is drawing this way. This is the way how you can think about as something looks like a triangle. So this one and that one has essentially towards increasing the electronegativity. Okay, so toward this direction from here, left to right, bottom to top, and in this direction, this is a electronegativity increase. So now look at the question. There is a P, and there is a Fr, and there is a lithium. So where is a P? There it is. There is a P. Where is the lithium? There is a 1. Where is the Fr? Actually, I cut it off, and Fr is right at the bottom here. This is an Fr elements here. So therefore, the one is the closest to the fluorine in this corner must be the P. So that must be the highest electronegativity. And among these two choices, this will have a higher electronegativity. Right? This will have a lower, weaker electronegativity. Right? So therefore, the lithium goes to next, and the weakest one is the one that really farthest away from. This one is really the farthest away from the fluorine, so that will be the smallest. So answer for this will be number B.